All right, let's dive into something truly mind-bending. We're going to tackle one of the biggest ideas in all of science, the multiverse. But here's the twist. What if even an infinite number of universes still have to follow some really strict rules? Let's see if we can unravel this cosmic mystery.
Okay, so let me ask you this. What if this morning, when you chose coffee over tea, you didn't just make a choice? What if, in that instant, a whole new reality branched off where you picked the tea? And what if both of those universes are completely 100% real? Believe it or not, this isn't sci-fi. It's a serious scientific idea.
And this wild idea, it's actually the core of what's called the many worlds interpretation of quantum mechanics. It's a bold, it's elegant, and yeah, it's a pretty mind-blowing attempt to make sense of the absolute weirdness that happens at the tiniest scales of reality.
So what exactly is it? Well, the many worlds interpretation, or MWI for short, says that whenever a quantum system has more than one possible outcome, like an electron that could be spinning up or down, the universe doesn't just pick one. Nope, it does everything. It literally splits, creating a separate, parallel universe for each and every possible result.
So yeah, that means there's a universe out there where you took that other job, one where you caught that train you missed, maybe even one where you became a world-famous astronaut. It also finally gives us a clean answer to that famous Schrodinger's cat paradox, right? In one universe, the cat's alive. In another, it's not. No paradox at all, just two different, equally real worlds.
Okay, but this whole everything happens idea creates a massive puzzle. If every single possible outcome happens somewhere, it seems to completely break something we rely on every single day: probability.
I mean, think about it. When you flip a coin, you feel like it's a 50-50 shot. But if many worlds says a heads universe and a tails universe are both created, where does that feeling of 50-50 even come from? Why does it feel like some things are way more likely to happen than others?
And this is really the heart of the problem, you see? On one hand, the theory predicts this endless, infinite branching of all possibilities. But on the other hand, what we actually see in the real world, what countless experiments have confirmed, is that quantum events follow these incredibly precise mathematical rules of probability. How can both of these things be true at the same time?
And that rule has a name. It's called the Born rule. It's the formula that lets us calculate the odds of any quantum outcome. And here's the thing. It works. It works perfectly. It's not just some guess. This thing is one of the most precisely tested pillars of modern physics. So for the many worlds idea to hold up, it has to explain why our universe acts like it's following the Born rule, when in theory, anything and everything should be happening.
So how do we solve this? Well, the key, the breakthrough that just might fix everything, comes down to answering a really fundamental question. Is the mathematical heart of quantum mechanics, this thing called the wave function, actually a real thing? For the longest time, physicists were split on this. Is the wave function epistemic, meaning it's just a tool we invented, just our state of knowledge, kind of like a weather forecast that tells us the probability of rain? Or is it ontic, a real physical thing that actually exists out there in the world, like the storm cloud itself, the forecast or the storm?
Well, guess what? We now have an answer. A series of groundbreaking new experiments have come down hard on one side of this debate. The evidence now strongly suggests the wave function is ontic, the storm is real. And honestly, that changes everything.
Okay, so here's why that's such a game changer. If the wave function isn't just some abstract math on a blackboard, if it's a real physical thing, then it has to play by the rules of the physical world. Let's see what that means for the multiverse.
Think about it. In our universe, real things, energy, momentum, electric charge, they all have to obey conservation laws. They can't just pop into existence out of nowhere. And if the wave function is a real thing, well, it shouldn't get a free pass. It has to follow the rules too.
So let's just connect the dots here, step by step. 1. The evidence says the wave function is real. Check. 2. Real stuff has to obey conservation laws. Makes sense. This leads directly to 3. There must be some kind of selection law that decides how new universes can even be created. And that leads to the absolutely stunning conclusion in step 4. Only the universes that are consistent with the Born rule, only those have the physical right to actually exist.
In other words, physics itself seems to be pruning the branches of reality. It's like universes with incredibly tiny probabilities just don't have enough of this physical reality stuff from the wave function to actually get made. So the multiverse isn't some chaotic free-for-all. It has a bouncer at the door, checking IDs.
And this leads to a really fascinating and kind of creepy consequence. This new rule might just save us from a bizarre thought experiment known as quantum immortality.
See, in the old version of many worlds, the one where anything that can happen does happen, you get this spooky idea. The logic goes that no matter what danger you face, there's always some ridiculously improbable universe where you survive. A random quantum event saves you. And since your consciousness can only continue in a world where you're, well, conscious, you'd find yourself living forever, surviving one bizarre, impossible event after another.
But this new idea of a selection law, it basically pulls the plug on quantum immortality. Those 1 in a trillion chance universes where you miraculously survive, those are exactly the kinds of branches with almost zero probability. And according to this new thinking, they just don't have enough physical stuff from the wave function to get past the bouncer and actually form. So, thankfully, immortality is probably not guaranteed.
And so, this all leaves us with one last really deep question to chew on. If the Born rule, this law of probability, isn't just a tool for prediction, but is actually a fundamental law that decides which universes get to be real, what does that say about our reality? Is the very fabric of the cosmos woven from the laws of mathematics itself? It's a thought that suggests the line between what is mathematically possible and what is physically real is far, far stranger than we ever imagined.